All right, so we're going to continue with 11.3 here, example 3. Just a quick reminder, the 3 and actually 4, I think I might have put this on yours already, but I left it off on 1. But there's also what we call a uniform distribution. And you may have seen that on the assignment too, but that's where everything's basically balanced. Okay, so you have normal distribution where most of your data falls in a clump in the middle, kind of trails off both ways. Then you also have your skewed left and skewed right, which is when your normal data has outliers off in one direction, either to the right or to the left. And those are your 4 basic types of distributions. So this example 3 says, is the following variable likely to have a normal distribution? So we're basically saying, does it seem like this would be something that would have normal data? So the heights of all people in a large group. So I've talked about this a few times, but generally speaking, yes, heights in a large group, you take all the school-age children, you take everybody in a grocery store, you take everybody at a concert, whatever, and you measure everybody's height, it should follow a pretty normal distribution. The only time that would be not the case is maybe you do it at some kind of specifically sort of weird place. Like, you do it at a basketball practice where there's probably more likely to be taller people or something like that. But for the most part, yeah, this is definitely going to be normal. So this says a normal distribution can be modeled by a bell-shaped curve, which is this bell shape here, that is symmetric about the mean, meaning it's balanced on both sides. This is called normal curve. Approximately normal distributions can be found in many real-world situations where the data is symmetric. So remember, symmetric just means it's equal, like on the same, identical on both sides. So like your skewed left and skewed rights would not be symmetric, but your normal or uniform data would be. So here's like a sample graph of what it might look like. If you surveyed a bunch of people of their heights, you have a lot of people in kind of this middle range. There might be a few outliers off in each direction here. But for the most part, definitely following a normal type of curve. So yeah, and that's going to be one of the main things here. Is they're going to give us different scenarios, and we have to decide what type of distribution it would be. And sometimes they give us a graph, and sometimes they don't. So this one says, probability landing on each of 8 equal parts on a spinner. So imagine like a little spinner, like the game Twister or something. You hit the little spinner, it spins around, lands on a thing. If it has 8 just equal spots on it, they all should be equally likely to come up. This is going to be what we call uniform. And I think that one's fairly obvious. I mean, the graph itself is fairly uniform. You're going to get a few that come up a little more or a little less likely just off random chance. But overall, it's pretty flat. Scores on an easy test. So if the test is really easy, then a lot of people are going to score really, really well. So you're going to have a big clump of high data over here. But there's always a few people who tend to do poorly on easy tests too. So it's going to skew to the left a little bit. So your big clump of data is here, but it does trail off towards the couple people who did do poorly on it. So this is referred to as skewed left. And I always just think of it in terms of where's my clump of my data at? Most of my data is over, in this case, in one area, and there's a few trailing off to the left there. Now, if they just said the score is on a test, then I would expect it to be pretty normal. But on an easy test, you're expecting a lot of high scores, very few low scores. Next one, number of children in a family. Even without a graph, you could probably figure this out. But 0, 1, 2, 3, 4, like the less children is going to be more common. There are very few families with 6, 7, 8, 9, 10 children and so on. So in this case, big clump of data here, few trailing off to the right. This would be skewed right. Okay. And so even if they don't give you the graphs, you should be able to kind of reason through scenarios like these to be able to think what type they would be. And so this is what you're going to see a little bit of in the assignment today is some just scenarios, some just graphs. Sometimes they'll give you both and kind of ask you to sort of determine what kind of distribution you think it is. On example 4 here, it says, how would you classify the following data set? Describe the type of distribution, the center spread of the data. So this is a lot like the question we did at the end of the notes yesterday. So I'm going to go ahead and enter this in my calculator. I'm going to get all the data summary, and then we'll talk about what we should look for there. Okay, so I went ahead and I put my data in. Remember, it's just put my data in my list. I went over to stat, calc, one more stats. So then I get all my information here. So I'm going to kind of talk about ways you want to look at this. When it says, how would you classify the following data set? We're looking for our distribution. Is this normal, skewed left, skewed right, uniform? What do we think? So and then from that, we're going to decide which measure of center and spread, but let's worry about that once we decide the distribution. So what I like to do right away is I look at the mean and I compare it to the median. So if my mean is 97.06, my median is 98. Those are really close to being the same number. So whenever the two are basically the same, it means your data is pretty symmetric. And if your data is pretty symmetric, it's going to be normal or it's going to be uniform. Now, I think we can take a look at it and figure out if we think it's going to be normal or uniform if we take a look at some of the spacing here. Okay, so we have, let's see, about 12 in between there, a little over 20 between there, a little over 20 between there, and about 5 in between there. So kind of a weird grouping here. This is one of these that I would call probably mostly normal. And a lot of these you have a little bit of play with it, but the same median and mean, or really close to, is a good indicator that you probably have a normal set of data. And we don't have, I don't know, it's close to uniform, I guess you could probably say. So you could maybe make a case for either uniform would mean that it's pretty balanced across, versus there's more points in the middle grouping. But I think I would go more normal than anything here. And so that's what I'm going to go with here. I'm going to say normal, or sometimes they'll even say things like mostly normal, or close to normal, versus maybe it just is normal if it's really obviously normal. Okay. Now, because it's normal, anytime your data is normal, you should use the mean and the standard deviation. So we can go ahead and give those numbers. That would be, the mean was 97.06 repeating. And then the standard deviation, again, if you don't have any background, use the population one. So standard deviation would be 18.06. Okay. And so that pretty much answers what this is asking for, is how would you classify, what type of distribution is this? It's a mostly normal distribution. And then because it's normal, we use mean and standard deviation. Now, just for argument's sake here, let's pretend that this mean was something way different. Let's say the mean was like 82. And then our median was 98. And those are way far off. Those aren't very close to each other in terms of like the realm of these numbers. So then we'd look at that and we'd be like, well, that's probably skewed left, because if the mean's getting pulled smaller, that's getting skewed towards the smaller numbers, towards the left. And then in that case, we call it skewed left. And then again, if it's skewed left, remember from yesterday's example, let me just flip to it real quick. Whenever your data is skewed in either direction, you should use the median and the IQR as your measure of center and spread. Those are the ones you should use to describe the data versus mean and standard deviation when it's normal. The big idea there is you're trying to pick which of these best represents the data based off the data's shape. Okay, so that's the concept with that. But this is what we're really looking for in terms of our answer in this case, because the data was pretty much normal. All right, there's one other thing on here I want to talk about. Sometimes we see box and whisker plots on like standardized tests, like SAT or any of those other tests you take sometimes. So I figured I'd talk about them. You don't see these very often in like media and writing, and too often, but you do occasionally. So I just figured we'd talk about it, let you know what they are in case you do ever see one. So what a box plot is, or sometimes called a box and whisker plot, because it's got a box and these two like whiskers coming off of it, is it's really just the 5-number summary. Okay, each of the spots that are graphed on this number line are part of the 5-number summary. This is the minimum. The next dot is the Q1. The middle line there is the median. The next dot, or the end of the box there, is the Q3. And the end of this whisker is the max. And so this gives you a nice visual way of showing the spread of the data as well. Like, so we can look at this, and in the same way that we looked at it on here, and we're kind of like looking at how far apart things are, this just shows it in a little bit. So this is a different set of data, sorry. But this just shows a little nicer picture, and it's a little easier to see what kind of shape of data we have. In this case, we have, remember, every one of these is a quarter of the data because they're a quartile. 3/4 of the data is packed in this small area, and then it stretches off in one direction, to the left, which would lead me to believe that this is more skewed left than anything, because we have a clump of data and a stretch or an outlier off in one direction. So this is just a visual way of showing the 5-number summary, and it can be pretty helpful for identifying which way the data is distributed. So just something to keep in mind. I figured I'd show it to you. It's a pretty minor thing. You'll see a problem or two in the assignment today, but this question doesn't ask it. But if it did, and if it was saying, which measures of data we should use, because it's skewed, we should use the median and the IQR. And I don't know exactly what they are. We could definitely estimate. This median looks like, let's see, this is going by what? eighths. So this is probably like 51-ish. And then the IQR would be subtracting these numbers. So I'd say that's maybe like 58. That's maybe like 47. So IQR there would be 11. So we could find those values. Like I said, this question didn't specifically ask for which measures you should use, but if it did have that question of, which measure of center and spread should we use, these would be the ones you'd select. But this question is really just asking about the shape. All right, so we'll wrap this up, see a little lesson summary today, and see how you're doing. Good stuff.